Alrighty guys, today we're going to be talking about combining like terms. We'll also be looking at some vocabulary that will be very important over the next couple of months while we learn about expressions, equations, and inequalities. You'll also take that vocabulary with you to algebra and beyond. So the next few lessons will be very important ones. So today we're going to be talking about expressions. Expressions are groups of numbers and variables, and they do not have equal signs. So they look just like equations, but an equation has an equal sign, an expression does not have an equal sign. So this big collection up here of numbers and variables is an expression. An expression is made up of terms. Terms are combinations of letters and numbers. Letters are variables. And then in between those terms, you'll have addition and subtraction signs. So we've talked a little bit about some of these words before, but let's just get them down on paper. A number in front of a variable, like right here, this says 3x, which we know means 3 times x. The 3 is called a coefficient. So the number in front of a variable is called the coefficient. The variables are the letters. In this case, the variable is x and it represents a number. These last two terms right here, the -4 and the 3, are called constants. Constants are just numbers with no variable attached to them. So this expression has a total of, let's count them, a total of 1, 2, 3, 4, 5 terms. You'll notice that when I circled the terms, I included the symbol right in front of each term, because just like with expressions, just like with integers, the sign in front of the term goes with that term. All right, so today we're talking specifically about like terms. We touched on it a little bit last time when we learned about the distributive property, and we said that like terms had to have the same variable values. So terms whose variables and the exponents on those variables are the same are called like terms. You'll hear me talk about like terms a lot. So they either have to be, there's a couple of important things here. Oh no, not yet. So let's highlight in this box all the like terms. So everything with just an x is a like term. Just an x, not an x squared, because they would not have the same variable and exponent. They have to have the same variable and exponent to be like terms. So we highlighted all of the terms with x. Now let's highlight all of the terms with x squared. Oops, do you see where I forgot an x? Right here. Now let's highlight everything that has a y. Just a y. And you'll notice everything that's left doesn't have a variable. Remember, those are called constants. Constants are like terms, so they have to have the same variable and exponent on that variable or have no variable. So those are my like terms. Some things to keep in mind: if a variable has no number in the front, let's look up at that box and see, like here's one that doesn't have a number in the front, here's one, here's one, here's one. So they don't have a number in the front. It's actually, the coefficient is a 1. So this one would be 1x, 1y. This one would be -1y. So just remember that if there's not a 1 in front, or a number in front at all, it's a 1. All right. So we already talked about this a little bit, that the coefficient takes the sign that's in front of them. So this right here, -x would be -1x. All right, let's take these expressions and put their like terms in the circles. So for example, We'll put all the x terms in here. We have 6x. We have x or 1x, right? Those go together because they both have x's. Now let's put everything that has a y, a 3y, and a negative 5y in this one. And lastly, let's take all the constants, negative 3, 12, and 2. Notice I'm always including the symbol in front of the term, so we know that's a negative 3 and a negative 5y. Now, so all we've done now is identify the like terms, but now let's actually simplify it. So the instructions will be to simplify it, not solve it, because we can't solve it. We don't know what the variables are, and there's no equal sign, right? We can only solve an equation because that has an equal sign. So let's combine like terms to simplify this expression. So let's start with the x's. We have 6 x's and another x, so altogether we have 7 x's. We are just adding the coefficients, and remember, if there's not a coefficient, it's a 1, and then keeping the variable part the same. So for the y's, we have a 3y and a negative 5y. So we said we're adding the exponents. Oh, goodness. So if we had a scoreboard here, we'd have 3 positive y's and 5 negative y's. So the negative team would win by 2. So negative 2y, we have 2 more negative y's than positive y's. And then we can just go ahead and add these constants. I'm going to add the positives together first to get 14, and then add negative 3 to 14 to get 11. So this is my simplified expression. I have taken that original expression and combined like terms to simplify it. A couple of things that are just common practice in algebra that we're going to start doing all the time to get you used to it is the constant term is always written last. And then if you have more than one variable, they're going to be alphabetical. So x comes before y. That's how we're going to write it. Okay, let's try our next expression here. See if I can zoom in. Nope. So we're going to take all of the terms with an x squared and write them here. And then we're going to take all of the terms with an x, which is 1x, negative 7x, and put them here. And then it looks like we have 3 constants left. I have a negative 7, a 9, and a 2. And I'm going to combine them. So I did the x squareds first because that's another common practice, is that if we have x squareds and x's, we can't put them together because they don't have the same variable and exponent, but we put the highest exponent first. Now that's actually something you're not really going to see this year with the having exponents on our variables. We're learning more about linear expressions, which don't have exponents, but that's just, I'm giving this example just to show you. And so we could talk about how we write the simplified version and how we organize our terms. So how many x squareds do we have? We have 2x squared and 4x squared. So we have 6 of those. And remember, if it doesn't have a coefficient, it's actually a 1. So 1 plus negative 7, or negative 7 plus 1 is negative 6. Don't forget the x. And then 9 and 2 make 11. 11 minus 7 would give us 4, and that would be the simplified version of that expression. And then again, we're used to getting one number as our answer, and that's not necessarily going to be the case anymore. When we're dealing with expressions, we're simplifying. It's simplified when we have no more like terms to combine. Alrighty, thanks for watching.